Imagine a time machine that works perfectly, but can only send information to the past, not people. Could this solve the paradoxes? Maybe. If you send a message to your past self, they might change their decisions without creating a paradox. But what if that change prevents you from sending the message in the first place? This is where the principle of self-consistency comes in, which states that the universe won't allow causal actions to contradict themselves. In other words, you can try to change the past, but reality adjusts to keep things consistent. It seems like time has its own rules to avoid confusion. Next topic, the many worlds interpretation. Imagine every time you make a choice, the universe splits into multiple versions where each possible outcome happens. This idea is the many worlds interpretation of quantum mechanics. Applied to time travel, it suggests that when you change the past, you don't alter your original timeline but create a new branching one. So, if you went back and stopped your grandparents from meeting, you'd create a new universe where you were never born. But your original universe, where you exist, stays intact. This theory sidesteps paradoxes by allowing infinite parallel realities. It's like time travel without breaking anything, but it raises questions about which universe is real, and what happens to all those alternate versions of ourselves. Time travel and free will, when we think about changing the past, a big question comes up. Do we really have free will in a timeline that might be fixed? If the timeline is self-consistent, then every action a time traveler takes was already part of history. This means your choices in the past were always destined to happen, which challenges the idea of free will. On the other hand, if multiple timelines exist, then your free will could create different realities with each decision. But this raises another problem. If you can't change your own timeline, is traveling to the past really meaningful? The debate between determinism and free will becomes central in understanding if and how we could change the past without causing paradoxes. The role of quantum mechanics in time travel. Quantum mechanics introduces some fascinating possibilities to the time travel debate. At the microscopic level, particles behave in ways that defy classical intuition, showing phenomena like superposition and entanglement. Some physicists speculate that quantum effects might allow for subtle changes in the past without causing paradoxes. For example, in the many worlds view, every quantum event splits reality, meaning a time traveler's actions could influence one branch without disrupting others. Also, certain quantum models suggest that information might travel back in time without violating causality through what's called quantum retrocausality. While these ideas are highly theoretical and not yet proven, they hint that the strange rules of quantum physics might hold the key to understanding how or if we could change the past. Time travel in popular culture. Time travel has long fascinated storytellers, fueling countless books, movies, and TV shows. From Back to the Future to Doctor Who and the Terminator, popular culture explores the thrills and dangers of messing with the past. These stories often dramatize the paradoxes we've discussed, like accidentally erasing your own existence or causing unexpected consequences. While entertaining, they also shape how we think about time travels, possibilities, and limitations. Interestingly, many narratives embrace the idea of multiple timelines or fixed time loops, reflecting real scientific debates. Pop culture keeps the mystery alive. It's inspiring both imagination and scientific inquiry into whether time travel could ever be more than fiction. The ethics of changing the past. If time travel to the past were possible, it would raise profound ethical questions. Should we interfere with historical events? Would changing one tragedy save millions, or inadvertently cause worse outcomes? The butterfly effect, where small changes lead to huge consequences, warns us that even well-intended actions might backfire dramatically. Moreover, who decides what changes are right? If someone could alter the past, it could be abused for personal gain, political power, or erasing mistakes. These dilemmas highlight that the power to change history isn't just a scientific issue, but a moral one, requiring careful thought about responsibility and consequences. The psychological impact of time travel, thinking about changing the past, also brings up psychological challenges. For someone who could travel back, the weight of knowing future events might be overwhelming. Guilt, regret, and the temptation to fix mistakes could dominate their decisions. But altering the past could also lead to unforeseen consequences, causing stress or trauma from unintended results. Moreover, Living in a timeline where events are fixed might cause feelings of helplessness or fatalism. Time travel stories often explore these emotional struggles, showing that beyond the science, the human mind faces deep challenges when confronting the possibility of rewriting history. Technological challenges of building a time machine. Even if time travel is theoretically possible, the technological hurdles are enormous. Creating a device to manipulate space-time would require energy levels far beyond anything we can currently generate. Concepts like stabilizing wormholes or generating exotic matter with negative energy remain purely hypothetical. Additionally, controlling the exact destination and time and ensuring safe travel poses massive challenges. Scientists are still far from developing practical methods, and some argue that the laws of physics may fundamentally prevent such technologies. The gap between theoretical physics and engineering reality remains vast, making time machines a distant dream for now. The impact of time travel on history. If time travel to the past were possible, even minor changes could ripple through history with massive effects. This is known as the butterfly effect, where small actions cause large, unpredictable consequences over time. Altering one event might prevent wars or disasters, but it could also erase important cultural developments or create new conflicts. Historians and scientists worry that tampering with the past could make the future chaotic or unrecognizable. Therefore, any interaction with history via time travel would require extreme caution, as the full consequences of changes could be impossible to predict or control. The possibility of parallel timelines. One popular way to resolve time travel paradoxes is the idea of parallel timelines or multiple universes. According to this theory, when a time traveler changes something in the past, they create a new branch of reality that exists alongside the original timeline. This means their actions don't erase or alter their original history, but instead form a separate universe with its own future. This concept aligns with interpretations of quantum mechanics and helps avoid contradictions like the grandfather paradox. However, it raises questions about which timeline is real and whether travelers can ever return to their original reality. While it provides a neat solution to paradoxes, parallel timelines also multiply the complexity of time travel's implications. Can we ever prove time travel? Despite decades of theoretical work, no direct evidence exists that time travel to the past is possible. Scientists search for clues in cosmic phenomena like cosmic strings or unusual signals that might hint at closed time-like curves. But so far, none have been confirmed. Experiments with quantum particles show strange behaviors but don't prove macroscopic time travel. Until we observe real effects or build functioning devices, time travel remains speculative. Proving its possibility would revolutionize physics and our understanding of reality. But for now, it remains a tantalizing mystery at the edge of science. The role of quantum mechanics in time travel. Quantum mechanics adds a fascinating layer to the time travel discussion. Unlike classical physics, quantum theory allows particles to exist in multiple states simultaneously, a principle called superposition. Some interpretations suggest that this could permit branching timelines, where all possible outcomes of an event happen in separate realities. Moreover, quantum entanglement and teleportation show how information can be linked across space instantly, leading some to speculate about connections across time. While quantum effects don't provide a clear path to practical time travel, they open theoretical possibilities that challenge our classical notions of causality and time flow. The influence of time travel in popular culture. Time travel has captured human imagination for over a century, inspiring countless books, movies, and TV shows. From H.G. Wells' The Time Machine to Back to the Future and Doctor Who, stories explore the thrills and dangers of changing the past. Popular culture often highlights the paradoxes and moral dilemmas involved, shaping how society views the concept. These fictional accounts influence scientific interest and public understanding, sometimes inspiring real-world research, though largely speculative. Time travel remains a powerful narrative device that pushes us to question our relationship with time, fate, and free will. Ethical dilemmas of changing the past. If time travel to the past were possible, it would raise serious ethical questions. Who decides what changes are acceptable? Should we prevent disasters if it risks erasing lives that followed? Could altering history for personal gain be justified? these dilemmas challenge our sense of justice and responsibility. The potential to rewrite history puts immense power in the hands of travelers, with risks of unintended harm. Ethical frameworks would be necessary to govern time travel, but agreeing on them could be nearly impossible. These moral concerns deepen the complexity of whether we should even try to change the past. Could time travel affect free will? Time travel paradoxes force us to question the nature of free will. If the past can be changed, does that mean our choices are predetermined or can be altered? Some theories suggest that if a timeline is self-consistent, then every action a time traveler takes was always part of history, implying a deterministic universe. Others propose that creating alternate timelines preserves free will by allowing multiple outcomes. The interplay between time travel and free will challenges philosophical and scientific ideas about choice, destiny, and the flow of time itself. The scientific challenges of building a time machine constructing a device capable of time travel faces enormous scientific hurdles. It would require manipulating space-time in ways far beyond current technologies, such as creating or stabilizing wormholes, generating negative energy, or harnessing cosmic strings. The energy demands alone are astronomical, and the unknown side effects could be catastrophic. Moreover, theories predicting time travel often involve conditions not yet proven to exist. Scientists continue exploring these concepts theoretically, but turning them into practical machines remains a distant goal, perhaps forever out of reach. The endless fascination with time travel remains one of the most intriguing and complex ideas in science and philosophy. While theoretical models suggest it might be possible under certain extreme conditions, paradoxes like the grandfather and Bootstrap Paradox challenge our understanding of causality and reality itself. The concept pushes the boundaries of physics, quantum mechanics, and ethics, forcing us to reconsider free will, destiny, and the nature of time. Despite the many obstacles, scientific, logical, and moral human curiosity keeps the dream of changing the past alive, inspiring stories, research, and endless debate. Whether or not we can ever truly change the past, the paradoxes and questions raised by time travel continue to captivate and inspire us to explore the very fabric of the universe.